Hey, what's going on, everybody? How are you doing? Happy Monday. Hope you guys are doing super good today. We are going to kick things off immediately into some more Kerbal space program. Why? Because I'm really hoping we can have our first Kerbal crew missions done today. That is the goal. We have a couple that we have to do. One, of course, is go on a suborbital flight on the DCX vehicle, hopefully fully automated. And the other one is to actually test, unmanned, but test our new space shuttle that's currently sitting out on the pad. Now in Discord, I believe it was No Names came through with a pretty interesting idea that I would like to try. And his idea was for our DCX vehicle, which essentially comes back towards the pad for a landing like Starship does in a belly flop configuration. Basically, it's pointing towards the local horizon, right? And it's basically pitching up and pitching down to move further downrange or to reduce its downrange, basically trying to guide itself back to the pad. The vehicle is not stable in the roll control with how the vehicle is currently designed. So No Name suggested actually having, during that belly flop configuration, at least until it gets to around Mach 1 or something like that, to actually have it go 45 degrees, because that actually creates a wedge, right? Like the entire vehicle is basically a box shape. It's a square if you look at the cross section. So he suggested rotate it, 45 degrees, so that way one of the points is angled down, and that should give us a nice symmetric cross section to have it remain stable through landing. So I think that's what we're going to try, chat. I think we're going to give that a whirl. And there's also a couple other things that I want to implement here to try and improve our capabilities. And by improve our capabilities, I essentially mean improve our ability to land back at the pad, ideally much closer. Like if we could do it within 100 meters, I'd be super ecstatic. I don't know what it's going to take to get to that point, but that is certainly the goal. I don't even know if that's possible exactly to do with our current setup, just using PIDs, but I'm hopeful, chat. I am certainly hopeful. All right, that looks pretty good. Yes, indeed. Perfect. Okay. So this is our DCX vehicle. It's a reusable suborbital platform. Kind of think like New Glen's New Shepard that goes on suborbital hops. We're hopefully going to be able to certify the DCX vehicle for flight and then put Kerbals on board to take them on suborbital hops to get them to at least level 1. Any Kerbals that go on board to at least level 1. Posture check. I see you, Erudite. How are you doing, bud? Posture's doing pretty good right now. All right. So let's get this back on the pad. We'll do a quick few hop tests and then hopefully a few operational tests, and then maybe put the first Kerbals on it. If not, then we have a mission 1.7 kilometers away that we also need to fly into space as well. So we got things to do, people to see, chat. How you doing on this Monday, Erudite? Hope you're doing well. So yeah, this vehicle is designed to be kind of like a New Shepard style vehicle. Go straight up, come straight back down, all that jazz. I'm doing good. How about you? I know adult life is busy life. True that, my friend, especially as we talked about here on the stream before. I believe it is Wednesday. All of the current contracts for the United States Space Force are coming due. So yeah, company and I are writing a few, so that's definitely going to be what I'm going to be doing. It's going to be probably a shorter stream today because of that. Get back to writing since there's only a couple days left, but yeah, it's doing all right, doing good. All right, we'll tease it and bring it right around here to our test pad, and we'll bring it to a nice easy stop right there. Perfect. And then now all we have to do is unlock, gizmo this down to where it is hopefully taking some of the mass. There it is. Brakes are on, check. Go ahead and move the traverse rate up a couple degrees, not that much, like to 4, yeah. Then that one should go to 90. And just like that, should be looking good here. Go ahead and gear drop. Very good. Perfect. All right. Alrighty then. So that seems pretty good there. Let's go ahead and increase the traverse rate there. Drop that to like say 98, even 104, something like that. Kick this up, and we should be able to undock and drive on out. And bring it up. Sweet. Now we'll get the crew here, the grounds crew, to some arbitrary safe distance, which seems right about here. What's up, Thomas? How you doing? By the way, Chad, just as a fair warning, not that this... how's it going, Kukos? Do you host the code on GitHub? I sure do. I believe the description below the video has the current GitHub link. All right. So for those of you on the Twitch side, this is a full disclosure. Because Twitch ads have been getting so absolutely obnoxious, I'm going to try something new today. I am going to try to run ads manually at times when there is nothing going on. So that way, if you do get an ad, it's not going to be like in the middle of a launch or anything like that. No explanations are going on. I'm going to try to do that. So fair warning, an ad will probably be run here soon. And we'll just kind of chill until that's over, right? So that way you guys don't miss anything, because it really caught my attention on the Flight Test 4 launch when literally I ran ads and then you still got ads during launch, and that is just not okay. So not okay by me. So hopefully we can fix that issue. So now that this is here, let's go ahead and click on over. Let's go ahead and fuel the rocket. Looking good. If you're wondering what mod this that allows you to do this for the pads here, it is Kerbal Constructs, both with a K. Doing good, glad to hear it. Yes, happy Monday. Fill this all the way up, and let's go ahead and get our code that we have been developing thus far. So this is what we have. There's a few things that I want to hey, what's up, Milu? How are you? There's a few things that I want to implement today. One, like I said, I think it was no names. Twitch being Twitch. Yeah, Twitch always being Twitch. One of the things that I want to try here is probably somewhere like here. And not only here, but also probably here. Yeah, here. I want to implement basically a gate where we're going to actually have it fall at a 45-degree roll. Because No Names in Discord a couple days ago gave a really good idea. If you've guys, we're going to actually launch it and hopefully be able to see what I'm talking about here. But this vehicle, because it is symmetrical and it actually has a lateral instability, meaning that, you know, a wedge shape is the most aerodynamic. So when we want to fly with the flat bottom first, it will have a slight roll just due to the aerodynamics, and the aerodynamics just blow it away. Where hopefully if we actually have it roll to a 45-degree angle instead of a 0-degree angle, it'll actually fall in this wedge shape here and be much more stable. So that's what I'm hoping for, and we're going to give that a whirl. I think you might also need to check your ad settings, which is very aggressive if it's just the stock settings. I don't run ads, which is why I'm going to start, so that way you don't just get the Twitch ads. You know what I mean? So hopefully that will take all Twitch ads out, because I was looking at that before stream, that if I manually run ads, you guys should not get any Twitch ads. So long as I do it, I think it said I have to do 3 minutes of ads every hour for you not to get any ads. So I'm hoping that's what we're going to test today. That's what I'm hoping we can test today. All right. Is this vehicle rotating? Yes. Yes, it is. It is in fact rotating. Why? I don't know. Don't ask. But it is. Anyways. Anywho, let's go ahead and fly it without any modifications to the flight code here. just to see what we're working with at start 0. And let's go ahead and do it. Let's also F5 so we can return to the state without having to go through the whole recovery stuff. Spin me right round, indeed. And go. So hopefully we have a nice nominal takeoff. It should pitch over. I think we last time got rid of the roll program, so it shouldn't roll until it basically reaches apoapsis. There it goes. Oh, it did roll. I thought we took out the roll program. I mean, it's not really that big of a deal, just I thought we had taken it out. It was very stable though, so honestly, maybe I'm just fine leaving it the way it is. I mean, it is nice to have it roll. We have pitch. I think what I need to do is I have autopilot engaged and I don't call target roll to be nan, and nan is basically KRPC, the mod that I'm using to do this. KRPC's way of saying, okay, we're just going to leave roll the way that it is. Either that, or I could even set target roll to be like the current vessel roll, so that way it actually doesn't roll at all. But that seemed pretty stable, so maybe we'll just leave it as is. Alrighty then. Let's go ahead and time warp up. So we're going to time warp. Our apoapsis should be, I think, around 70 kilometers altitude. There we go. 73, not bad. And it was probably because we actually probably overshot even more because I was time warping through the calculations. But not too shabby. Dun, 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 dun. All right, looking good, looking good. And there's Apo. And there's pitch over maneuver. So like I said, it should now enter what SpaceX has coined the belly flop mode for its descent. And you see, we're right now basically, like, if this had wings along the side, we're basically falling wings level. But like I said, this is actually the moment of inertia that's actually unstable. It's actually the minor axis of the vehicle, where most vehicles are stable around the major axis, and the major axis happens to be at the 45-degree angle. So this is the major axis of the vehicle. So yeah, any little bit of aerodynamic forces that cause even just a little bit of roll is going to have this vehicle start to just kind of like pitch over. So hopefully this is one change that we can make to where it's actually going to fall at a 45-degree angle in the roll. So that way the wedge is basically going first, and that should be much more stable. Low frames per second. Yeah, so yeah, technically, because it's basically what causes the low frames is KSP's physics tick rate. I don't think the frames are actually affected. It's just the game simulation time changes. And so you have a slower sim rate, so your vehicle or your sim looks like it's stuttering and stuff. I think that's how that works. But yeah, regardless, yeah. If you see it acting slow, like we're in the yellow or whatnot, then that is definitely a telltale sign. Another good thing to do is try to figure out when we actually need to go wings level. This probably needs to be around, I don't know, 10 kilometers maybe? I don't know, we need to check our velocity at that point. So now we're starting to hit the really, really big atmosphere. And you see it's starting to, it's not stable in that configuration, so it immediately wants to go into the wedge. Ooh. Hey, what's up, Captain Failure? How are you? Oh, there it goes, and now it's coming back around. It's trying, chat. It is so trying. But see, that's what I'm talking about. The aerodynamics really cause it to kind of go out of control a bit. So where are we? We're in 2B, or not 2B, that is the question. Yep, that seems fine. Cool. All right, we're slowly translating back towards the pad. Hey, what's up, Sea Kraken? How are you? A program that's more successful than Starship HLS will ever be. Hey, look at that. Spicy indeed. So we're still doing okay. Our landing pad is right there. That circle, basically where we took off from. It doesn't look like we're gonna have enough to get back to it though. We are going pretty fast, but we're falling like a rock. We might get back to it. Let's see. We go here to trajectories in flight. Oh, there it is. Nope, we're not gonna make a chat because it's gonna pitch over at 1500. Yep, there it goes. So yeah, that was a perfect example as to why we need to do what I'm thinking about doing. What did you think about the Starship TPS new rumors? I'm not sure I've heard anything on that front, to be honest with you. What were said rumors? I mean, I feel like it's pretty fair that they need to figure out some sort of design changes on the TPS. But I think we've known that for quite some time, right? The tiles, no matter if they do a static fire or whatever, they always have some that fall off, and there's a reason now that we've actually seen live as to why that's a problem. But yeah. All right, so yeah, see, not great. It's not very stable. So let's go ahead and load it back. So before I do that, or as I do that, chat, like I said, I'm going to try something new today. So on the Twitch side, I'm going to run some ads because this is going to be a moment of downtime. Literally, I'm going to do nothing. I'm going to wait for y'all to come back. So that way we don't have ads run in the middle of the stream like has been happening. So sit back, relax. There will be a few ads and then we will be right back, chat. All right. So yeah, while those ads are running, going to take a little chill time. We're going to reload. There we go. So yeah, basically we saved here so that we can revert without having to go through the whole like drive the truck out there, pick it up, drive it all the way back and refuel it and stuff like that. We should be good to go as is. All right, not bad, not bad. I wonder if that stopped the spinning. It did stop the spinning. A reload stopped the spinning. Well, there you go, chat. There we go. All right. And is it fully fueled already? It is, in fact, fully fueled. Cool. So we F5'd in a good spot. So if we take a gander... at our code here, there's a few things that we want to be able to look at. First and foremost is we want to be able to set the roll here to 45 degrees, but that's not the only place that we need to do that. We also, I think we need to do that here in 2B because we actually immediately go into this mode after switching. After basically reaching our apoapsis when we actually want to be rolled at 45 degrees, and then we need to call that here as well. So that should be something that we need to do. Yeah. Okay. So we also need to figure out something to do there. And then another idea that I had was to change the input for... So we implemented that to where the distance to the pad, but I also want to see about changing this as well, mainly the target pitch, to actually be a function of our horizontal velocity and distance to the pad, to be a little bit more aggressive, to where if we are very close to the pad, say within, I don't know, 500 meters, and moving faster than say 50 meters per second, then we probably want to pitch up at like 70 degrees, right? Really try to slow down if we can. That's probably something that we want to do as well. All right, looks like the ad should be done on the Twitch side. So Seacracker says, I've been thinking this for a while now and don't really know how to code it. How would you do a targeted orbital reentry with KRBC with a capsule? Targeted in terms of what exactly? Yo, when Erudite pushing out the meme tax, appreciate that. What do you mean by targeted reentry? So one way, if you mean to like re-enter such that your capsule, which should be more or less ballistic, basically lands within a certain landing ellipse, like a target, you would need to, of course, have your landing site defined. So your latitude, longitude of your landing site. And then what I think you would have to do is basically treat your trajectory as an orbit, right? Because it essentially is. You should be able to propagate and understand your overall orbit, even if it's suborbital trajectory. And then you should, I don't remember what it is off the top of my head, but you should be able to find the intercept time for when you land. So basically, what does that mean? You basically have an orbit. You know what? Maybe if I draw this out. Yo, what's up, Grab Shark? How are you doing? Within a 1 kilometer region. Yeah, gotcha. Didn't the Apollo capsules use offset COM and roll to control reentry a bit? It certainly did. It most certainly did. And then Captain Failure, you said, oh, by the way, Sea Kraken, your module that you showed there in Discord looks absolutely fantastic. I actually really dig that. It kind of reminds me of something that we made a long time ago. But yeah, that looks really sick. I think there was a video of Musk saying that they wanted twice more strength for the tiles and also possibly an ablative layer between the normal tile and the steel hull. Yeah, okay. I feel like that might be a little overkill, but yeah, fair enough. Flight 5 in about a month after replacing the heat shield on the ship with a new tile twice as strong, ablative protection underneath will act as a secondary heat shield layer. Yeah, I'm hoping that secondary heat shield layer will be able to be removed once they like validate the new heat shield tiles, the stronger heat shield tiles, because that just seems like so much extra mass that might not be even necessary, but it would definitely be an improvement, right? You have redundancy and stuff, but how would you do that trajectory with arrow as well? So yeah, let's actually kind of figure that out a little bit here. So I want this, and then we should be able to write, yeah? Okay, so let's say this is going to be Kerbal, right? And let's say you want to land here, and then your capsule is on a trajectory, right? In this direction, around Kerbal. You are going to want to initiate your burn to go suborbital, right? And think of it kind of like a boost back burn, right? So you're going to be burning retrograde to, you know, put yourself on a suborbital trajectory. What you should be able to do is figure out, you know, basically maintain what your orbital parameters are, even as you're on a suborbital trajectory. Because remember, a suborbital trajectory is still pretty much an orbit. It's just, you know, that orbit actually ends up going inside of Earth, or in this case Kerbal. So you should be able to define your orbit and propagate that based on your velocity, right? And there is a way, and I can't remember off the top of my head, but there is a way to figure out the basically the time, or basically the point of intercept with the surface of Earth, or in this case Kerbal, based on your orbital parameters. So you should be able to calculate basically this latitude and longitude, and then you basically burn until your intercept, right? Your intercept point is basically equal to your landing site, your desired landing site. Right, it would basically be something like that I think you can do. Now, to add arrow into that calculation, that is definitely a little bit harder. I'm not sure if you could do that easily with this method. to actually add arrow, you would probably have to do some sort of numerical integration, basically define the equations of motion of your vehicle. And your equations of motion of your vehicle, right, are essentially just the sum of all forces are going to equal the sum of the force of gravity, right, plus the force of arrow, plus, you know, you can have whatever other terms you want to account for as well. So you probably would have to do it this way, because then from here you can actually figure out your latitude and longitude based on the forces on your vehicle, and you would account for that with, right, because you could also change this to be the total mass times acceleration equals the mass times acceleration of gravity plus the mass times acceleration of the arrow, and then you should be able to just break that down into you know, propagate that forward in time. Very, very similar to how we did the Euler integrator, right? Like, we developed a Euler step method here to actually figure out what our actual apoapsis is going to be, including the force of drag. So you might also be able to do something like this. Basically take the equations of motion, propagate them forward in time as you burn, and then figure out your landing zone based on that. There's definitely a lot of ways to do it though. Hey, what's up, Toto? One question. Did you study engineering? Yes, I did study engineering. I have my undergrad, my master's, and my PhD in aerospace engineering. Could you do a tutorial to start coding on KSP with Python from scratch? That I could certainly actually end up doing. That's actually not a bad idea, Juan. We've definitely gotten far enough into it to where we have a lot to now talk about. So yeah, I think we could definitely do that. If you want to, so that might be something that I have to make a YouTube video for, and probably because there's a lot. I mean, it's not a lot, but there's definitely a lot to it, right? Juan, if you're looking for, basically, if you want to start right now, then I would definitely recommend Google the mod, which is KRPC. So KRPC is the mod that we use for being able to talk to Kerbal. Yes, to be able to talk to Kerbal using Python, and it also supports a lot of different other languages: C Nano, C Sharp, C++, Java, Lua. But it does actually have very, very good documentation, and they have a discussion on how to get started, how to work with Python. They have a lot of tutorials and examples to like go ahead and get started. So definitely, if you're looking for something like right this second, I would highly recommend just looking at the tutorials and examples. And otherwise, yes, I think I can most certainly get a YouTube tutorial session going here, maybe this week. Yeah, absolutely. Let me see what you say here, GraphShark. KRPC actually allows you to connect into trajectories. Oh, well, there you go. That might be perhaps an easier way to do it, Sea Kraken, because yeah, trajectories mod, which is another mod that we actually use, right? Trajectories actually does that line that we see during flight is your intercept with the surface of Kerbal. So you might be able to, if GraphShark says that it can tap into that, you might just be able to do that and basically burn until trajectories landing zones within a certain amount of a certain distance away from your desired landing point. That sounds easier for sure. I tried to do an LES, and every time I tried to fire an SRB from a tag, it broke the KRPC code. Advanced stuff. It hooks with either KOS or KRPC, not sure which, but I think it doesn't matter. There are ways to send data from KOS to KRPC. Oh, okay. Interesting. But anyways, chat, let's go ahead and now that the ads on Twitch are over, let's go ahead and start figuring out the things that we want to improve here. So, as I was talking a little bit here during the ad break, there's a few things that I want to improve on this vehicle. One, like I said, is I think we should be more stable if we are basically re-entering at a 45-degree angle, basically using the natural wedge shape in this direction to stabilize the vehicle, because this would be the major axis of the vehicle, which it would be stable around, and this is more of the minor axis, using the flat plate side. So like any sort of perturbations that give us a roll causes the vehicle to just completely go unstable due to the aerodynamics. So I think the first thing that we can try here is, first we want to initiate a roll at 45 degrees, But this is not the only place we need to do this. Why? Because we essentially entered this quick loop after touching our apoapsis and starting to go down. And then we immediately go into mode 2B, or not 2B. Yes, mode 2B, and we are immediately calculating our roll as if it was going wings level, so 0 degree roll. So I need to actually update this now as well. What's up, Teague? How are you doing? But my brain is so smooth right now to catch any of it. Understandable, understandable. Was inspired by this and now have a launch script. It's mad, but it works. Hey, so long as it works, like, that's half the battle, right? That is half the battle for sure. Yes, so what I think I want to do here first is we need to change that, and then I think we want to have it change. Let's actually try the certain altitude first. So we're gonna have here, as we're falling, if Talim dot vertical, no, we want to do we actually want to do the altitude, surface altitude. If our surface altitude is, say, greater than 9,000 meters, 9 kilometers in altitude, right? Then we want our vessel dot autopilot dot target roll to be equal to 45 degrees. Else, it's going to be the calculated roll input, which is actually calculated based off of our heading error. I think that's what we're going to do. KRPC PID controller. Ah, yes, I can certainly do that as well. Yeah, we can, if you guys are interested, we can definitely break down a lot of this code into different tutorial videos, if you will. How do you know how much to burn back? That's what we were actually talking about before, Teague. So one of the ways to possibly do it is you either just integrate the equations of motion of your vehicle and calculate your landing point, and then you just burn until that calculated landing point is within some vicinity of your actual landing, your desired landing point, right? That's kind of a way to brute force it. I think another way you can do it, which this would not account for aerodynamics. I wonder if there's a way to actually include aerodynamics into this, but you can also think of your trajectory as an orbit, and you can actually use your orbital elements, even though it's suborbital, to figure out the time until you reach the surface of Kerbal, right? Because you know basically on your orbit where that surface of Kerbal is going to intercept your orbit line. And from there, you should be able to do the same thing. Calculate, like, okay, transform this position on my orbit to a latitude and longitude. Does this latitude and longitude equal, or, you know, within some threshold around my desired landing point? There's probably a lot of ways to do it. Those are the two that I've been kind of thinking about doing myself for, like, a boost back burn, but I haven't thought too much about that yet. All right. Okay, so the KOS KRPC thing is called KIPC, and the trajectories KOS stuff is here. Oh, KSP KIPC. Okay, okay. Let me open those up, because I'd be kind of interested in seeing what that's all about as well. There. Neat. Okay. So going back down to what we were changing here. Right here. So if Talim.surface altitude is greater than 9,000, so basically 9 kilometers altitude above the surface, we want to maintain a 45-degree roll angle, so that should help us remain stable during the descent. And then otherwise, we're going to want to basically roll wings level, calculated by the roll input, which is based on our heading error. So hopefully that can be something that helps keep us stable on the descent. Now, there was one other thing, chat, that I wanted to figure out here, and I think we have a problem with overshooting, right? Which is, you know, it happens. The vehicle is mostly able to account for it, but I'm wondering if we can actually improve it even further, which would be, so here's this, and our pitch calculation here. Yes, doing something very, very similar to where if our distance to the pad is, say, less than 500 meters and our horizontal velocity towards the pad is, say, greater than 50 meters per second, then basically pitch really, really high nose up to try and slow down so we avoid the pitch, right? So we avoid the overshoot. That's kind of what I am thinking here. This would be a kind of just a very simple way to do it. So we need to be if our Talim dot horizontal velocity is greater than 50 and our distance to pad calculation, our linear distance to the pad, is less than, God, we're going like 100 meters per second, so maybe 900 meters 900 meters to the pad and going greater than 50. I don't know how fast the vehicle will be able to pitch up and slow down, so maybe we just try this first. And then else, and then we want this to be the else statement calculated. And then in a similar fashion, we want this to be vessel dot autopilot dot target pitch to basically just be really, really high pitch, like 70 degrees pitch up is what I'm thinking. Maybe that's too much. I don't know. I don't even know if a vehicle can actually pitch up at 70 degrees with all the aerodynamics going on, but we'll see. And I think that's it. I kind of think that is all that I want to do. Getting a headache, laugh aloud. I'm just trying to code. Hey, understandable. Understandable. Don't you worry. We're gonna take a chill pill. We're finished with all the coding for now. Now we just get to test it. We get to fly it, chat. That's what we get to do now. So, like I said, this is our suborbital test vehicle. We're gonna try and do all the things here, see if we screwed something up royally or if this works. So let's go ahead and fly this right meow. Nice. There we go. Vehicle's away. Dun, 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 dun. So yeah, this is what trajectories mod does. It basically shows you your actual trajectory and your indicated landing zone. So X marks the spot, even though it's not an X. That is our, basically, if we went ballistic from this point, we would pretty much go straight up and come straight back down to here. Yep. So based on our Euler integrator, basically our Euler estimator, we are targeting a 70-kilometer apoapsis, and that should include the force of drag. So essentially we should be burning over 70 kilometers to account for that drag, because we're trying to make it as accurate as possible to hit that 70-kilometer Kerman line as much as possible. So we're just going to be going forward here until we are around 60, somewhere right about there. And shut down. Perfect. So in reality, that's probably going to be more like 71, 71.5, but pretty close. Close enough for government work. It's more accurate as it should be, essentially, for shorter flights. So not going as high, but it's only within a kilometer of error. Pretty happy with that. All right, now we should be able to coast up to Apo at 72 kilometers. Could Dorito Shuttle carry this to LKO? You know, that's a good question. I mean, I know we're mostly empty, but what, how much mass do we have? Total mass 16 tons. Ooh, that might be a little much, considering, you know, it's actually mostly empty. Maybe though, maybe. Trajectories gets even nuttier if you have a lifting body style reentry. I had to use it to dial in my targeted dinosaur landings in a previous RO run. Nice. Yeah, with the angle of attack. Yeah, you can definitely do that with this, right? Is this what you're talking about? Yeah, you can pre-program based on the lift and drag of your vehicle, your entire approach for the most part, which is actually really interesting. All right, almost up to apoapsis. We should then enter a brief altitude hold. There it goes. And pitch over. All right, let's see. First thing to check is 45-degree angle. All right, there's our 45-degree angle roll. So like I said, in this configuration, we should be much more stable than we were. That's at least what I'm hoping for. And this was your face, indeed, yeah. Yeah, trajectories is awesome. I've been using it for, golly, probably more than 5 years now in KSP. It's super useful. All right, there you go. So you'll notice our current landing zone is in the middle of the water, but luckily we have a lifting body, chat, so we'll have to see just how well this does. Now, I don't know if we're going to be producing as much lift in this configuration than if we were essentially wings level, basically 0 degrees roll, basically pointing this way. But I guess that's something for us to learn here, huh? Yo, no names. It was you that gave us this suggestion, right? If I'm not mistaken. On Discord, we're trying it out, man. I'm hoping that, yeah, we should remain much more stable. Because this is the natural way it wants to fall anyways, so it should be stable. Also, one thing I didn't consider until just now, the way the RCS are actually positioned, we should actually have way more RCS control, like way more RCS authority in this configuration as well, because we can essentially get 4 RCS thrusters pushing us upward instead of just 2. So that's actually really interesting. Hey, what's up, Shock? How are you? I take the blame, by all means, by all means. Look at that. Wow, that's actually so much more stable. Uh-oh. Uh-oh. Baby. No way! No way did it just do that. And now it's going wings level for the flight. Oh my goodness gracious, chat. That actually might just do it. That actually might. If that is repeatable, then that's the way that has to happen. 100%. All right, we're seeing our calculations here. We're pitching up to 16 degrees. Once we get within a kilometer or so at this velocity, passing 154, it should pitch up to about 60 degrees. All right, we're pitching up even further. Once it passes 1 kilometer, it's going to pitch up to 60 to slow down. There it should go. There it goes. Oh, I'm sorry, pitching up to 70. Oh, we still might be overshooting. Oh dear. Okay, stand by. Looking good. We're almost coming down right on top of it. No way. No way. 15 vertical. Oh my Lanta. Wait just a second. Tease it. Oh, there's a flag. There's a flagpole. Huh. Huh. 90 meters away. Like I said, if we could land it within 100 meters of the pad, I'd be super ecstatic. That's all we needed to do, chat. Well, there was a couple things. No Names gets definitely the blame for that ingenious idea to actually have us descend in the stable configuration, as we should have the whole time, and then having it pitch up if it's a certain velocity, a certain distance away from the pad, to try and slow down to avoid overshoot. Wow. Wow. That's all I have to say. It's just wow. Not bad. What's up, Rio? How are you? All right. Well, I am Well, we have to try that again, right, chat? I mean, like I said, it has to be repeatable if we're going to put crew on board this thing. If we're going to put crew on board, we have to have this repeatable, 100%. I could have just been lucky. Could have just been Kerbal giving us a break, just to dash our dreams at the end. Yeah, pretty happy about that one, chat. Pretty happy. Yep. There we go. Okay. Fully fueled, fully fueled. All right, let's just send it again, chat, because that's what we're here for. There we go. Vehicles away. Pitched over. Nice. Casually flexing on everyone doing targeted landings. No Names is now the new lead engineer of the program. Ah, there you go. Isn't being a Kerbal about the whole 50-50 not making it? I mean, come on. If we land it twice, then it's a 67%. It's not quite 50-50. It's 67-33, right? Like maybe that's slightly better. You know, the odds are still forever in our favor, right? All right, let's go ahead and cruise back up to Apo. 70 kilometers. But yeah, that was so much better. Like, so much better. Wow. First action as lead is to resign. I thought you said redesign. I was like, oh yeah, okay, we're just gonna redesign the entire vehicle. Now that we have the software locked in, redesign it. Redesign it. All right, should be looking good here. Go ahead and cruise up to Apo. Yeah, exactly, failure. Because now this one is gonna fail, and yeah, stock market crash. Or not stock market crash, our company stock crash. All right, well, we're about to enter our brief altitude hold. All right, stand by. There we go, passed. Entering vertical velocity hold. Now, there we go. Exiting hold and now falling. Aim 45 degrees pitch. And rotate. Perfect, very nice. All right, well, that seems pretty good. Very nice. Very nice, chat. So yeah, we'll see if this one can be as pretty as the last. Because then maybe, just maybe, we can get our dedicated flight test astronaut Dr. Longballs in there. Maybe, just maybe. Got to keep an eye on our propellant, because last time we landed with like 130, I think, and this way does consume more propellant because of the way the attitude control systems are now working in this controlled dive. So definitely something to take note of. We are really working with like no margins on this flight. Sub 50, that'd be pretty crazy. Sub 50, I feel like we'd be like actually on that pad. Okay, looking good. Okay. Vehicle looks so stable in this configuration. Wow. We are 7 kilometers away, but approaching very fast. Oh, if that is all it will go off in terms of the attitude, that is brilliant. And now it wants to roll wings level. That's great. Bringing it back. There we go. Wow, that is so super stable, chat. Okay, we're currently expecting an overshoot, but that's fine. We're pitching up to try and regulate, rather. Once it goes beyond 1 kilometer, it should pitch up to 70 degrees. There's one, pitch up. Nice, try to slow down. That works pretty effectively. A very small overshoot, pitch down, aim for the pad. So we could actually even give ourselves more time than, say, the kilometer that we have right now. Oh, it might overshoot again this time. We'll see. Oh, it's coming straight down on the pad. Oh, no. Oh, no. We're 81 meters away at the moment. All right, tease it. There we go. Slightly worse, but around the same mark, 100 meters. Last time we were at like 94 or something like that. I mean, I'm pretty happy with that. I'm pretty happy with that. Huh. Okay. Well, did we put the first Kerbals in here, chat? Okay, well, as per our rules, we actually have to do 1 flight for certification, and then it can be granted operational status. So I need notepad, file, open. Shoot, where did I put that? Here. Yep. With a little tuning, I bet you could land exactly on the pad. You're probably not wrong. Like I said, if we really wanted to, we could probably give ourselves a little bit more spacing to try and avoid the overshoot even more. Because where do we have that? We have that here. Yeah, 50 meters per second and a distance. Oh, we don't even have it at 1 kilometer. Yeah, we can actually add that to 1 kilometer. I thought it was 1 kilometer, it was 900 meters. That actually might be pretty effective. You should do a bit of tuning. Okay, we'll do this little bit of tuning here on this flight, but I think I'm ready. This thing has been in development for a very long time. So we're gonna work here on a almost high enough mission number 4. Let's drag this out to be the same as it once was. There we go. Oh yeah, MI7, that was also a complete success. Bearing issue was fixed. Heck yeah. So we had that one. So yeah, this is going to be almost high enough for AHE. Flight number 5. I think this one was like 450 meters. Okay, so yeah, let's go ahead and copy this. Copy this one for flight test. Yes, good. It's going to be AEH5. We want to bring this in on day 610. We'll get that figured out here in a second. DCX, launch site TP1. Nothing. This is going to be... what do we want to call this? It's going to be flight test 1. or actually let's do demo mission 1. We'll go with the SpaceX terminology here. So uncrewed flight test demo mission 1. Now that we're locked in, successfully do that, land within 300 at, yes, very nice. Boom, boom, very good. All right, let's go ahead and bring the, oh, yeah, we gotta launch this as well, chat. This is on the pad waiting to launch, but we gotta do these first. Load test on the struts, away to the craft and speed at touchdown. We should be good on that, Lyle. It does descend at, I think I have it locked in at 5 meters per second, which might be kind of fast, but it actually typically goes even slower than that. I should say it lands no faster than 5 meters per second according to the control systems. And that seems to be pretty good. Let's go ahead and pick it up. We'll revert, and then we'll put it back out. Actually, you know what? We don't even have to do that, right? Yeah, this will be our demonstration mission. We'll just take it right here, put it back on the pad, refuel it, and we'll be good to go. You get a Dream Chaser on an Atlas. I mean, essentially, it's actually the crew return vehicle, which was a real-life concept developed by NASA to be a lifeboat for the International Space Station. Had full prototype development and flight, and then not even suborbital, basically airdrop test, and then program was then canceled because it was such a success. All right, let's go ahead and see what we want to do here. Back it up. That seems good. Bring this down. Perfect. There we go. Perfect. Drop that down. Drop this down. Take the mass off. There we go. That should be far enough forward. And then bring it up. There we go. Nice. You think they have any regrets? I'm sure they have. I'm sure some people somewhere have regrets. Absolutely. You know, it's kind of like, man, if we just had done this, we would have had this, you know, capability or whatever. Who knows? But I don't think NASA as a whole, certainly not. But maybe some program manager somewhere. I know, right, Misadventures? Do you just get lat plus longitude plus latitude? Yeah. How do you make it remember the craft's original position? Yeah, basically it logs wherever this takes off from as landing site, which is latitude and longitude, and then we use that as our location. So wherever this takes off from is the desired landing site. We make sure to log its position at the very start. Could have had a V8, I know, right? But yeah, exactly. Did EJ finish his truck stuff? Was in there for a little bit, but then started to stream. All right, that looks good. Let's go ahead and draw it down. Dun, 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 dun. You know, while I can leave seat, crew report. Okay. I was wondering, like, if, oh, that's what we use the light utility vehicle for. Yeah, that's what we use the light utility vehicle for. So I was just wondering, like, there's no real way for a Kerbal to ingress into this vehicle, right? Except through this docking port. But I was wondering, like, I don't think you can do that from the command pods, right? Yeah, you can only leave seats. You can't, like, swap them. So I think we had our light utility vehicle, which was designed to carry a a crew capsule in there with the people that would be the Kerbals that would be flying this vehicle, and then, you know, we just swap them in from there. Yeah, I think that's what we were doing, if I'm not mistaken. Anyways, not important at the moment. Okay. There we go. And once again, we will just put this into some arbitrary safe distance from the pad. And right here looks pretty safe to me, chat. I don't know about y'all, but doesn't this look safe? This looks like a safe distance. They just finished up. Nice. Are they still streaming, or are they hitting the road, or no, because of that fixing, they're not going to hit the road until tomorrow? Because I thought he was supposed to, they were supposed to leave today, right? All right. Let's go ahead and fill it up again. There we go. Very nice. Fully fueled. All right, well, let's go ahead and figure this out, chat. So we're going to be launching on day 203. Time will be approximately 5:48. We are on demo mission number 1, BCX from test pad 1. Looking pretty good. Those are all the same objectives. All right, we should be good to go. They're in a hold pattern cleaning up before they leave. They may not leave officially until tomorrow. Yeah, okay. Cool. The wheels on the transporter look cool. Thank you. Unfortunately, it's kind of a byproduct because my original design, right, had the medium size rover wheels. But with the current, because this is career mode, we actually don't have those medium wheels unlocked. So I took this design from a previous save. It had all of the parts necessary except for the wheels, so we changed them out for these rover wheels, and it works. It works okay. All right, chat. Here we go. This is our uncrewed demonstration mission. Hopefully, all of it. We did some slight tuning on that distance to pad mark, so now we should be 1 kilometer away before we pitch up really, really high. Should be good. And here we go. And we're away. Vehicles pitched over. Landing gear are stuck. We should be able to just retract. There we go. Because we had put them down from the truck and then separated the truck, it reset our action group. So the code toggled the action group, but it was already like off, so it didn't do anything. Considering the weather in Arizona, yeah, that's true. So you built the vehicle HL-20 that Space Dev bought from NASA, that SNC bought, that spun off to Sierra. Yeah, something like that. Something like that. All right, looking good, chat. Looking excellent. Probably after this flight, I might have to do another manual ad run on Twitch side so we don't get any ads in between, but hopefully we get this flight finished up before that has to happen. So that way you guys don't have any ads. How's that working, by the way? Have y'all gotten ads in between? I'm hoping not. I'm hoping that fixed that. Hey, what's up, Bettle? How are you doing? How are you doing, my friend? Hope you're doing well. All right, going up to an altitude of 70 kilometers. Again, this is all autonomous from here. Vehicle's looking good. Control point is stable. Let's go ahead and time warp a little bit. There we go. Targeting apoapsis of around 70. 72 is fine. Perfect. Just perfect. So right now we're cruising up to Apo, which is right there. And our landing zone is right there, chat. We'll see. Like I said, we've hit it 2 times. Can we hit it 3 times in a row? If that's the case, then I'll be pretty happy and Then we can do our space shuttle mission that's currently sitting on the pad waiting for flight, and then we can do a crew mission for this vehicle as well. All of the possibilities, chat. All of the possibilities. Just eating some leftover pizza. Ooh, that's sounding pretty great. Leftover pizza, nice. All right, cruising up to Apo here. Got another few kilometers to go. There's 70, 71, 72. And we should enter a brief altitude hold. There it goes, and pitch over. Okay, get the vehicle realigned, roll, and we're good. Okay, we'll see from here. I just realized the liquid fuel RCS is literally hot gas RCS, and the plume also shows it. Indeed, indeed, erudite. Yes, it's quite good. It is quite good indeed. Yeah, it's liquid fuel oxidizer. I mean, yeah, it can be any sort of hot gas thruster like monomethyl hydrazine and nitrogen tetroxide, or unsymmetrical dimethyl hydrazine and nitrogen tetroxide. Could even be methyl oxide oxygen, which is what Starship is to use, right? Anything with combustion for the thrusters. All right, we are cruising down, entering our belly flop mode. Vehicle is 9 kilometers away from the pad, moving backwards away from the pad at 50 meters per second. Looking okay. We are targeting a pitch down of 37 degrees to try and pick up horizontal velocity. And we are, yeah, we're looking good. We are at a 45-degree roll angle right now, and that's exactly what we want. Hopefully once we get back into the atmosphere, yep, it looks, oh, maybe not yet. Aerodynamics should start taking over here soon. Up, and there it goes. We are now moving towards the pad. Well, not moving towards the pad. We're starting to slow our backwards movement. Aerodynamics are coming into effect here, which is nice. 11 kilometers away. We are now moving towards the pad. We're moving towards the pad at 100 meters per second. I wonder why this one feels like we're so much further downrange than we were on the last flights. Like 11 kilometers, like, were we that far away last time? I don't know. I mean, I'm not really nervous yet. I feel like this vehicle can certainly manage that. It is a lifting body after all, but at the same time, it's like, it feels a little far, chat. Not gonna lie, it feels a little far. But we are gliding at 5 kilometers altitude. We're still traveling at 150 meters per second towards the pad. Yeah, we're looking good, actually. We are actually looking good. Okay. From 11 kilometers out, we are gliding back towards the pad. How about that, chat? If the same 6G is a little much, yeah, maybe a little bit, but oh well. All right, looking good. Wow, we are cruising back, chat. We are flying. All right, we should start pitching up to about 70 degrees. Trying to regulate that horizontal velocity. There it goes, 70 degrees. Pitch up. Really slowing down here. Bring it down almost right on top of the pad, hopefully. There it goes. Looking good. I am completely hands off. It's fine. It's within 100 meters into landing mode. Oh god, is it gonna land on the Kerbals? Maybe our arbitrary safe distance isn't so safe. Now we're fine. Totally fine, right, chat? Totally okay. It's doing this just for us to have an easy way to pick it up again. Wow. All right, not bad. 133 meters away. Yeah. I'm happy with that. We are consistently within the octagon here, or it's a hexagon, within the hexagon here. 10 out of 10. Thanks, Musical. Not bad. Yeah, our automated guidance is pretty much on point, if you ask me. We went really far down range too. I have to keep an eye on that. Like 11 kilometers down range seems like a lot. Yeah, see? Oh no, we were far enough back. Look at that, chat. From the center point, we were actually even further back. If you look at linear distance, look at that. Totally fine. Even if that truck was parked right here, would have been okay. Yeah, arbitrary safe distance. That's safe enough. All right, well, I am very happy about that. So let's what do you guys say we leave them here for the moment, and while that happens, they can take a look at this vehicle, which is about to launch. We got to get this vehicle's flight system operational, and before I do that, just while I'm looking over and checking the code chat on Twitch's side, I am going to run some manual ads. I run manual ads as a test for today because Twitch ads seem to have gotten very aggressive. So I'm hoping that running my manual ads will keep you guys from getting ads when there's actually things happening. So like I said, just going to be reviewing code, going to have some downtime here, and we'll be back here shortly. All right, well, that is going. Let's go ahead and get the correct flight guidance out. That's going to be the Minerva 1 launch vehicle. All right, and for Minerva 1, for this guy, we do need the abort system. Yeah. And how does this actually operate here? If is abort installed, abort trigger check. And then enters abort steering. SAS is engaged. And it does nothing if vessel.thrust is less than 0. Separate the docking port. Okay, that actually should be good. Yeah, that should be nominal. I'd actually really like to check that. Because what we should do is now, is abort install? This is going to be true. And the abort criteria for the off angle is 20 degrees. I think that's fair. Yeah. Is abort installed? Abort criteria. Abort trigger check. If the pitch error is greater than the abort criteria, then yep, okay. Should be good. There's a KRPC Discord. There is a KRPC Discord indeed. All right, that seems good. All right, checking everything else. You know what, by the way, chat, you know what we should do? I need to bring back our checklist, I think. Let's go ahead and open, actually, yeah, let me actually just go ahead and do it here because I want both of them up. So from our previous mission log here, we actually made a checklist for crew. Yeah. Yeah, this one. We're gonna go ahead and control copy that. Good. Yeah, don't need that. All right. All right, so we're gonna set up a quick checklist here for our Mercury shuttle. Plus our Minerva 1. Pre-flight checklist, chat. That's what we gotta go here. All right. So control from here, KRV probe core. Change name of craft and priority set to base 20. Set controlling probe core tag to control point. Yes. Yes. Yes, yes, yes. I think basically everything can be used as is, actually. So let's just go ahead and do that, and we'll run through the checklist and make sure we're good to go for this launch. Because like I said, the way that we play our hardcore career mode here is if anything goes wrong during operation, if it's not like a in-game Kraken Strike bug, we're not reverting. And when we have our flight software running things, well, we better make sure everything is actually working out. So, yeah. We are going to go through this and probably update it, because some of them are actually not required, because this is actually used to be for us also having to fuel our vehicle on the pad and stuff. That last landing was hilarious. A little bit, yeah, a little bit close there, but hey, we're fine. This is gonna be the M1 or the Minerva 1. Okay, that seems fine. Okay, yes, should be good. Okay, so let's actually run through this checklist and update it as is required. All right, control from here, the probe core. So we will do that. Change name of craft and priority set to 20. Yes. So that actually means that we need our upper stage to not be that way. Because that is, it should be down this way somewhere. There it is. Yeah. We are going to need to add that. Or Mercury shuttle probe. Set controlling probe to control point. And then we actually want 2.3, which is going to be change name of M1 upper stage to lower priority. And then 2.4, remove remove M1 upper stage tag. Ensure control point is not set. Okay. Ensure all of that. Ensure RCS on KRV is locked out. Check abort system activation. Open abort motor valves. Unlock tanks in case of the abort. Ensure KRV has been refitted with parachutes. Open all RCS tanks on first and second stages. Open all propellant tanks on first and second stages. Ensure ALV sits properly. So we don't actually need that one. That's good. Begin with outermost prop. We don't have to load prop. Ensure entire first stage is fully loaded with prop. That actually might be good to do. Begin prop load. Ensure second stage is filled with prop. That will be 10. Prop load closeout. That's going to be 11. Well, actually, no. Prop load closeout. We don't actually need a prop load closeout. Same script, pretty much. I looked up and you'd landed right next to the truck. Indeed, yeah. It was our arbitrary safe distance really came through for us. First stage engine checkout. Throttle and gimbal set to nominal. Yep, nominal. Second stage set to nominal. Enable port staging on pad. So that's actually not required anymore. Set pad disconnect. We don't need that anymore. Rearrange stack staging to nominal configuration. Ah, yes. Basically check your staging. Do I have that elsewhere? Rearrange stack staging to nominal configuration. So that's going to be 12. Ensure pad docking port. Don't need that. Confirm action groups. on the KRV and vehicle are set. Awesome. Confirm ARV and pad are go for launch. Confirm Mercury and M1 are go for launch. Open VS code, confirm proper GNC is initiated. Rename root vessel is set to KRV shuttle name, set in position 2. Process controls point 2. Confirm, so that's going to be 14. This is going to be 15, 16. Confirm control point set to KRV probe core. That's good. Deprecated, skip. Yep, don't need that. Okay. Set target inc. Set altimeter bias. That's going to be 9.1, 9.2. Final review of GNC. Open arrow GUI data panel. 14, 15, 16. This is going to be 17 actually. That's going to be 18, 18, 18. Yep, there we go. 19. This is going to be 20, 21. That can be 21. Don't need that one. Prime pad disconnect. Don't need that one. Confirm expected launch time. That's going to be 22, 23, and 24. All right, chat. There we go. 17, not 18. This one you're talking about? Or this one? I think we're good. I think. Let's actually do 17.1 just to be consistent with our other ones. Yeah. Because we did that here, just 11. There was no 11, 11.1, just 18.1, 18.2. All right, fixed it? Okay, cool. That's good. Looking good, chat. All right, so let's actually run through it, yeah? Just to make sure everything should be good to go. So, first and foremost, PC1, process control 1. Control from here, KRV probe core. So we should be able to come into the top here, command, control from here. All right, very nice. Change name of craft and priority set to base 20 for Mercury shuttle probe. Yes, so that's going to be priority. Very good. But we do want to configure vessel naming. It's going to be a base, and we're going to name it the same as our target here. So Minerva-1. So it's going to be Minerva-I. Accept. Okay. Set controlling probe core to control point. Change name tag to be control point. There we go. Control underscore point. Perfect. Change name of M1 upper stage to lower priority and unset. Unset its control point allocation. All right. Configure vessel naming. That's fine. It's going to be a probe and yeah, accept. Perfect. And change name tag. Accept. Okay, perfect. All right, we're looking good so far. Change name, so we already did that, and remove M1 upper stage tag. Perfect. Ensure all RCS control surfaces, all control surfaces are locked out. So yes, we want that to be inactive. We want that to be inactive. Sorry, other way around. Okay. There we go. Perfect. Looking good. Ensure RCS on KRV is locked out. I should really do this. Oh, it's not even full of monoprop. Yikes. Okay, good to know. I guess we won't be flying with any monoprop. Oh, we have some monoprop there. Good. Good to know, good to know. All right, that's fine. Check abort system activation or an abort action group. We should have checked that already and we should be good. Yep, that's fine. Perfect. We also have abort action here. True, set to 20 degrees off angle. Perfect. All right. Check abort system activation and the tanks are unlocked. They are. Ensure KRV has been refitted with parachutes. It's good. Open all RCS tanks on first and second stages. We're fine. Yep, that's good. First stage engine checkout should be nominal. Second stage engine checkout should be good. Rearrange stack staging to a nominal configuration. Yes, let's check our staging, shall we, chat? Aha! Already off the mark. Yes, that's why we have a checklist, chat. All right, so that looks good. Why is that? Oh, that's actually something we don't even need to have done. 17.1 is actually 17.1. Wait, what? What you talking about? We have 17. There is no 17.1. Should be okay. All right, so staging check here, chat. So that's fine. Those are not fine. That's not fine. So we're gonna move these. Good. That certainly is not fine either. And neither is that. So this needs to come down here. Then this needs to come down here. No, not there actually, but I need another. There we go. Okay, I definitely need to revert and you're skipping 18 to 18.1. Yes, to remain consistent, right? Because we have 18.1 here without an 18, as we did here with 11, as we did here with 5.1, as we did here with 2. So that's why. Just for consistency, because I already made that mistake. All right, that looks good. So that's fine, that's fine. Then we should have pad separation. Very good. That's okay, that's okay. That's fine, but that is not. So that should come down here. And then same with this one. That one, and that one. Which one is that actually? I don't think that's actually right. Part, aim camera. Oh, is it actually correct? Oh, it is. Okay, cool. I was thinking it was supposed to be this one. But no, we're good. Yep, that looks good. That all looks fine. Oh yes, those solids actually should also be down here on the SEP. Yep, very nice. That's fine. And then that's the very top. Okay, I think we're good now, chat. We are gonna F5 here because I wanna test something, chat. I wanna test an in-flight abort. Because that should all be automated, right? We have it here. Is abort installed? True. The abort criteria is 20 degrees off angle. Basically, if the vehicle's starting to pitch over too much, it should activate the abort sequence. So let's go ahead and do that, yeah? So I should have F5 here so I can revert to this point and not have to go through all this all over again. So let's do it. Here we go. And main engine start, outboard engine start, and pad set. Very nice. Roll program. And pitch maneuver. There it goes. Uh-oh. Perfect abort scenario, chat. So that did not work. That was manual. That was not automatic. But hey, it worked. At least the abort sequence does in fact work, even if it's manual. This is fine. This is fine, chat. Don't worry about it. Totally nominal. Oops, wrong button. Oh, that's right. Mm-hmm. Stand by, chat. I want to check action groups. Do I have action group set? I have control from here. No, I do not. Well, that could be a problem as well. Wow, we really need to get back to the VAB and figure this out. There we go. YOLO, exactly. Miss this little guy, indeed. If you guys are unfamiliar with this shuttle design, it's actually based off of NASA's crew return vehicle, which was meant to be a lifeboat, a very small return shuttle from the ISS. And it actually does do what it's about to do right here, which is land under parachute. So of course our vehicle lands under parachute. Perfect. Hey, what's up, Intense? How are you doing? There we go. Just like that. So let's load that back, and clearly, chat, clearly we need to have a way less aggressive pitch over maneuver, because that was not intended. Let me tell you what, chat. That was most certainly not intended. So our pitch over maneuver needs to be way less aggressive. So I think for it to be way less aggressive, I need to implement this. I need that to be higher. Oops, accidentally exited. And then from there, yeah, that should be okay. Pitch roll, yes, that's fine. All right, well, we can try that again and see. We just definitely need it to be way, way less severe. So let's see if that is going to fix that issue. I know, right, Intense? Truly. Should be good. And set. Because the roll program is very nice. But the pitch over maneuver is a little aggressive. I could also give these more gimbal if I need to. Yep, see, it's already maxed out. This is fine. Don't worry about it, chat. Totally okay here. And abort. That's fine. Oh, wow, that is super maneuverable in the abort scenario. This is fine. Don't worry about this, chat. Totally nominal separation event. Everything about this is perfectly fine. Everything about this is fine. Yep. Totally nominal. Totally nominal. All right, so clearly, chat, I need more gimbal on our vehicle, which it has plenty of. The only reason why we tuned it down is because it was too much to begin with. But maybe now it does actually need to be more for this vehicle. Well, like I said, the abort does work, even if it's a little hectic. All right, yeah, let's try that again. This time we're going to increase the gimbal on the first stage engines. Whew. Definitely more gimbal authority. Does the fairing on top of the booster make it dragless or whatever? No, only the abort. It should, I don't want it to make it dragless, you know? So no, it does not. Only the abort system is housed in that. All right, let's see what happens if I instead do this. Control, let's boost that up to like double, 60%, yeah? Yaw and pitch, and then these are just roll control, right? Yeah. No, these are on everything. Okay, that's fine. We'll increase these a little bit as well. Yeah, it's fine. I just want to see if this vehicle can even remain stable under that condition, because I feel like it definitely should, but we'll see, I suppose. All right, try this again, shall we? Rocket Gal made dinner, chat. We'll have to call it quits here soon. We'll see if this goes well, and then go from there. Here's a good roll program. Come on now. Stay stable through the pitch. No, what are you doing? Why is this so aggressive, chat? I'm actually kind of surprised by that. Up. There we go, chat. This is fine. Nope, not fine. Less fine. Totally less fine. Is it actually adjusting? Okay, there we go. Maybe. Nope, too much. Is the arrow really that bad? I mean, I know it's a lot of arrow at the very top of the vehicle, but I would have thought the fairing to help out at the bottom, and then that these would definitely have enough gimbal authority. I would have thought anyways. Clearly that's not true. Oh, this is fine. Yes, do a twirly down into impact. That's totally acceptable. Not nearly as fine as it once was. Yeah. Headphones. Oh my. And with that explosion, we went underground. Huh. All the scatter immediately left the surface of the earth. Anyways, one more test here. I'm gonna try to make the pitch over way easier, which is actually something we very recently learned by working with the DCX vehicle, so maybe that is the better move here. Let's see, enable staging, yes, pad separation, that should be fine, and then autopilot engage. That should be fine. Target, pitch, and heading. But where's the roll? Where do I initiate roll? That's target and pitch. Oh, it's because of the target pitch that we have the roll? No. Where's the roll program? I know I have one. That's target, pitch, and heading. Auto tune. Oh, roll program is there. Ah, yeah. That's basically having it just go straight. Okay. Yeah, I don't think I want this sleep rate to be so much at all. I think that's what's really killing us here. Let me actually go into roll program and see what we have. Target, pitch, and heading. Mission params.target roll.weight. Yeah, that I think should be fine. And then I'm wondering if I even need this then. Yeah, I want to test it without these, just out of curiosity. Because so what this weight does is we recently learned that the KRPC has a built-in blocking function, so that way it will actually stop the code here until the target roll is met, which might be a lot faster than having that like 5-second timeout that we had and then entering pitch. So I'm wondering about that. I just want to see what that's going to do. And then if we come down here, let's just increase that all the way up, because I'm curious to see if this vehicle can even remain stable with the gimbal that it has. And that should be a lot of gimbal too. Hey, Goldwinger coming in with the lurk. Lurk away, my friend. All right, let's try this one more time, chat. Boop. So now it should go to roll, and then almost immediately after roll, start the pitch, which should hopefully keep it from commanding such a massive pitch over. Yeah, it is for that particular function, yeah. Because it's a dynamic sleep, if you think of it that way, right? Uh-oh, or it just doesn't work. Oh, mission params. Wait, I'm silly, chat. I'm silly. Stand by. Yeah, don't. Yeah, How do we do it here? I think it's got to be the actual control. Where did we put that? Yeah, don't mind the vehicle, it's fine. Autopilot, yeah, after I set it, then I do autopilot.wait. Okay, that's what I do. So we set it. Yeah, that makes sense. I'm silly. Then we do vessel.autopilot.wait. And that should work. There we go. Pay no attention to the vehicle. Indeed, it's fine. It's totally okay. Don't even worry about it. Okay. Yeah. Because that wait function should allow us to pretty smoothly change from roll maneuver to pitch maneuver without having to like wait for like 10 seconds. So that 10 seconds wait time means that the vehicle is continuing to calculate the pitch updates, but we're not pitching over. So what that means is that after 10 seconds, our commanded pitch is going to be like, say, 10 degrees, and because we were waiting that whole time, so it's immediately going to want to do a 10-degree turn. Whereas this should actually help us avoid that wait time, since it should maneuver into that roll program pretty quickly. So that is the goal. There we go. And here we go. Last test. So long as it flies, whatever the outcome is, we will go from there. Engine start. Outboard engine start. Pad set. And roll. Good. Should get it locked in. Oh wow, it's taking a really long time. Pitch. And pitch is still way too much. Incredible, chat. Incredible. All right, well, clearly we're gonna have to fine tune some things here in the very near future. But unfortunately, that is going to have to do it for me tonight. So I hope you guys enjoyed the stream. Got some really excellent outcome from the DCX flight systems, but now that we added all of this lifting surface on the very top of our rocket here, it's very unstable, obviously. So we're going to really need to try and hone in the flight dynamics of this vehicle for our flight software. But then once we get that done, chat, then hopefully we should be able to have pretty routine flights of this vehicle, get it certified, get our first crew up, all of that jazz. What? I just came back to this chat, I'm not gonna lie. Oh, there we go. Yep, I just came back to that. I have no idea what's going on. The shuttle just wants to fly, chat. It just wants to fly. That's all. That's what it's telling me. But anyways, have a good one. Have a good one, chat, and catch you guys back here on the flip-flop later. All right, so have a good night, everybody. Toodles. Next stream should be Wednesday. GG, that's right, GG.